Thank you, Guillem, and hello, everyone. It is nice to be here today. I'm Georgia Koutrika, and together we are going to walk through the INODE architecture. So in our use cases, we heard about different kinds of data sets: astrophysics, policymaking related data, biological data, and these are actually just examples of the different data sets that are generated by users, by systems, by sensors nowadays. And these data are used to drive processes, but also to drive many aspects of our lives. The key here is to understand that while for many people, data is considered to be the 21st century most valuable commodity, its value becomes obvious when we have the right tools to leverage the data. So at this point, I would like to to take a look at existing data exploration tools that we also had the chance to see some examples through Guillem's and through the other use case presentations. And here I would like to sum up some of the most important limitations that come with these tools. And let us first take a look at how the user can say to the system what they're looking for. And here we have essentially two cases, two scenarios, either a form-based interface, like the very nice interfaces that Guillem showed us earlier, where the user can interact with specific interface elements that will help him formulate their query. But of course, this type of interfaces only allowed limited query exploration capabilities. As Guillem mentioned earlier, essentially these form-based interfaces hide specific types of queries that can be asked. And if the user is looking for something else, then this is not possible. Now, the other extreme is to have a low-level query or programming interface where the user can, for example, use SQL or Sparkle or some other programming or query language to write exactly the code that will bring the data that they're looking for. But now the catch here is that this user must be an expert in this type of technologies. They must also understand very well what their data they're saying, and they must also understand exactly what they're looking for. Otherwise, it is very difficult to come up with a query or the code that exactly describes what data you're interested in seeing in front of you. Now, let's take a look at how the system communicates with us. And here again, we have two essentially different ways, either tables that show the results of our queries, or dashboards and reports that show more, if you like, in a more user-friendly way, some graphs to tell us possible insights or possible patterns that are hidden in the data. All these are good, but still we miss here in interpretation of the results that will help us understand what we see here and where we need to go in order to satisfy the information need that we have. There is no explanation of why we see these results here. So we see a table here. I'm not exactly sure what is the next question or the next query I should ask, so the system doesn't provide us any clue on how to proceed next. And last but not least, the data itself. So most of these exploration tools actually assume that you have a known static source, a data source with a known schema. So it's very hard to actually find, link, and query new related sources. And essentially what we heard from the use cases presentations earlier are some of these needs that come up in these use cases, but also in other similar examples. For example, with the policy making, we heard that we need to enable powerful queries for non-technical users. And in fact, these comprise the majority of the users that we see in these scenarios. In astrophysics, we need to make the interface to data more natural for users, because for scientists, it is most important to ask the queries, not to understand how they should ask the queries or how they should formulate the right queries that the system understands. In cancer biomarker research, we see that we need to allow users to query other sources, and we need to allow ontology-based integration and access for this to happen. So essentially, three very fundamental requirements and challenges form. We hear about data accessibility, how we can enable more natural interfaces to data. We hear about user guidance, how we can offer guidance to users through, for example, explanations or recommendations so they can find the data they want, so they can formulate the right queries. And of course, last but not least, data discovery and linking, how we bring together, how we link, we combine data sets, and how we allow these data sets to be queried in a rich and meaningful way. So that brings us essentially to INODE, Intelligent Open Data Exploration. And our core principle here is that users should interact with data in a more natural, intuitive way, similar to a dialogue with a human. So we want to enable users to link and leverage multiple data sets, to access and search data using natural language, examples, analytics, and paradigms like that, get guidance from the system. So we want the system to be more active towards the users, provide explanations, provide recommendations, and also allow the users to visually explore the data and discover new insights. And this is essentially, this leads us to our system architecture, where you can see the 4 big components, the green ones, the orange ones, the blue ones, and the gray ones. So the orange ones are all about data linking and modeling, how we bring together different data, how we build ontologies on top of the data so that we can allow more meaningful and more rich querying over this data. We also need capabilities for knowledge graph generation. When we have unstructured data, documents essentially, how can we extract information out of this text and allow querying this text in a more structured, more meaningful way? Then we have the green parts, where we have essentially data access and exploration capabilities, where we allow the users to ask queries in natural language, not in SQL or Spark or these very difficult languages, but also other types of data access and exploration paradigms through exploration operators, like by example and analytics. We also have user assistance components that allow the system to provide explanations of the queries that the system understands and executes on behalf of the user, recommendations on what other queries the user could explore from the point that he is right now, and of course, visual result exploration and manipulation. All of these sit on top of the blue components for integrated query processing that essentially allow all these components to query in a meaningful and in an efficient way different data sources in a transparent way. Last but not least, we have evaluation. And here we have logging mechanisms for essentially keeping track of what is going on in the systems, how the users interact with the system, and then mechanisms that allow us to qualitatively and quantitatively understand the performance, the effectiveness of the system. Evaluation is a big part and is also very hard, another hard challenge for our system. So at this point, I would like to thank you. It is time, as Kurt said, to open up for short Q&A, and then coming up, we have the demo.